Hi, in this video, we are going to understand about one of the page replacement algorithm, that is optimal page replacement algorithm. In the previous video, we have seen one of the page replacement algorithm that was first in, first out, or FIFO page replacement algorithm. So if you have not watched that video of the FIFO page replacement algorithm, you can find the link of that video in the operating system playlist in the video description below or here in the I button. So let's start and understand what is this optimal page replacement algorithm with the help of example. So in the previous video, when we discussed about the FIFO page replacement algorithm, we discussed about that what is the problem in the FIFO page replacement algorithm. The problem was FIFO suffers from the Belady's anomaly. Anomaly means unusual behavior. So what is that unusual behavior? Normally when we allocate more number of frames to a process, then its page fault should decrease. But what happens in FIFO? Sometimes for some of the reference string or for some of the, you can say, page references, it happens that when we increase the number of allocated frame, then the page fault get increased instead of getting decreased. Okay, so this is the unusual behavior which was detected by the Belady's. Okay, so this behavior or this unusual behavior is present in FIFO. Okay, we saw one example in which when we increase the number of frames, then for that reference string the page fault get increased. Okay, you can find the link of that video again in the operating system playlist. You can watch that video. Okay, so this is one of the disadvantages with the FIFO page replacement algorithm. The next disadvantage you can talk about is in FIFO, there is no importance given for the heavily used page. Okay, FIFO actually just see that what is the page that came first in the memory. Okay, that is the oldest page and I have to replace that page only. Okay, so it is like a straightforward, you can say, page replacement algorithm. So let's say if a particular page is getting used a lot of time, then FIFO does not take into account that thing. Okay, it simply replace the page which was the oldest or which is the page that came first in the memory. Okay, for example, let's say we have this reference string. Okay, so what will happen here, that the page 1, okay, which is getting used like many times, okay, 3 times the space is getting asked or the demanded by the process, but we will see that every time whenever it is asked, we will get into page fault. Okay, this one will generate actually page fault. Let's see how. So for example, we are given only 3 frames or we are allocated 3 frames for this reference string, or you can say for this particular process. Okay, so initially all these 3 will generate page fault, right? First I will take this one and I will place it in free frame. Then I will take 2, it will also generate page fault. 3, again it is not present, it will generate page fault. Okay, so till now everything is okay. Now 4 came, so 4 will say, okay, I am not here already present, so OS will replace the oldest page. Oldest page will be 1 according to FIFO. So 1 will be overridden by 4. Okay, 1 is replaced. So my new content is 4, 2, 3, right? Now here 1 again came. Okay, and here you can see 1 was just replaced by 4. Okay, so 1 will come and it will generate page fault actually, right? So again 1 will replace this. Okay, now 5 came and 5 will again generate page fault because it is not present here. Okay, so it is the content and 5 is not here, so 5 will replace this 3, right? Okay, now 7 came, again 7 is not present here, so 7 will replace this 4. Okay, because this is the oldest. Now this 6 came and now 6 will replace this 1. Okay, because according to FIFO this is the oldest page. Okay, so 6 will replace this 1. Now again 1 is asked. Okay, now you can see according to FIFO 1 was just replaced by 6 and after it was replaced by FIFO algorithm, again it is asked, so again it will generate page fault and 5 will be replaced by 1. Okay, so here you can see 1 is getting used again and again, but according to FIFO it will not take into account that which page is getting used a lot of time. Okay, I should not replace that page because it can create lot of page faults. Okay, so FIFO has no mercy on such type of things. Okay, FIFO will not take these things into consideration. It is a straightforward algorithm. Okay, so in the introduction video of the page replacement algorithm, where we discussed that what is the expectation from the page replacement algorithm, we want that the number of page fault should decrease. Okay, we want such type of page replacement algorithm. We should decrease the page faults, and with the increase in number of allocated frame, the page fault should decrease. Okay, so we want some another type of or better type of page replacement algorithm. We should take these things into consideration. So we will see another type of page replacement algorithm today. So that is optimal page replacement algorithm. Okay, which will actually tackle this type of problem. So let's see what is this optimal page replacement algorithm. So as I told you in the FIFO page replacement algorithm video, that in every page replacement algorithm video, we will be given some of the informations. What will be those informations? We will be given the reference string. Okay, reference string is the group of page numbers which are asked or demanded or referenced by the CPU at different point of time for a particular process. And then we will be given how many number of frames are allocated to that process. Okay, so here we are given 3. And then we will be asked, we have to find the number of page faults, or we can be asked like find the number of page hits. Okay, so again in the optimal page replacement algorithm also the same informations are given and same question is asked. So now the question is, according to optimal page replacement algorithm, which page should I replace whenever there is a need? So the answer is optimal page replacement algorithm actually see the future. Okay, it see that in the future which is the page that will not be used for the longest period of time. Okay, so if anything in the future I know that this thing will not be used for a longer period of time. Okay, I will not be needing that thing for let's say 10 years or 20 years, then I will not make any arrangement for that thing, right? So the same thing applies to optimal page replacement algorithm. Okay, it will see the future and accordingly it will decide which page should I replace. Okay, the page that will not be used in the future for the longest period of time, that will be replaced. Okay, so before going further, let me tell you the another name of the optimal page replacement algorithm is opt, or you can say min. Okay, so these are the other names for the optimal page replacement algorithm. So let's see how we can apply the optimal page replacement algorithm on this given numerical, and let's understand how it works. So again, we are given these reference string. We are given the number of frames which are allocated to that process. Okay, we are given 3 frames. Okay, and we have to find the total number of page faults generated after we or after the CPU reference these different page numbers. Okay, so let's start. So here is my reference string. Okay, I have again written this. Okay, now let's start with the algorithm. So 3 frames are allocated to this process. So I have drawn that 3 frames. Okay, initially all are free. Okay, so let's start. So the first page that is asked by the CPU is page number 1. Okay, so initially it is not present inside any of the frame, so this will generate page fault. So I will write tick. Okay, tick means this page generates a page fault. Okay, so 1 is placed here, right? Now the next page is 2. Okay, so 2 is again not here, right? So 2 will again generate a page fault, right? So 1 is here, 2 I will write here. Okay, so 2 generates a page fault. Now next page is 3. So 3 is asked, again 3 is not present here, right? So 3 will again generate page fault, right? So 1, 2 are already here, 3 is placed here. Okay, so in all of the page replacement algorithm, you will see that initially all the frames which are equal to total number of frames which are allocated. Here 3 frames are allocated, so first 3 will always generate page fault. You take any algorithm. Okay, so now let's start with the 4. So 4 is again not here. Okay, in the any of the frame. Okay, so 4 will also generate page fault. Okay, so 4 will generate page fault. Now the question is, which page should I replace? So optimal algorithm says that you are currently here. Now see the future. Okay, future is like in the forward direction. Okay, and see out of 1, 2 and 3, the page which are actually present inside these frames, which page is getting used after a very long period of time in the future. So see, 1 is actually used just after 4. Okay, so you will not think to replace 1. Okay, okay, next is 2. 2 is getting used after 1. Okay, now see 3. So you can say here it is 5. Okay, here it is 1. Okay, here it is 2. Here it is 3, right? So if you see this window from here to here, you can see 1, 2, 3. 3 is the page. Okay, out of these, 3 is the page which will be used after a very long period of time. So optimal algo will say that you can replace this 3. Okay, so I will say okay, 3 will be removed and 4 will be placed here. Okay, so I will say 1, 2 and 4. Okay, now let's start with the next page. So 1. Okay, so here you can see 1 is actually already present here, so 1 will not generate any page fault. Okay, so in the FIFO page replacement algorithm, we saw that this 4 was actually replacing this 1. Okay, due to which when we came to 1, it was generating a page fault here. But in the optimal page replacement algorithm, we saw we are not replacing this 1. Okay, we are saying the page which is getting used or in the longest time in the future. Okay, the page which are getting used just now in the future, we should not replace those. Okay, so now 1 I will write cross. Cross means it is like a page hit. Okay, it is not generating any page fault. Now see 2. So 2 is again here already. Okay, so it will not generate page fault. It is like a page hit. Okay, 5. So 5 is not present here. Okay, so 5 will generate page fault. Okay, so the question is again, which page should I replace out of 1, 2, 4? So I am currently at 5. Okay, so now see out of 1, 2, 4, see the future. So I will see the future. So 1 is here, 2 is here, and 4 is the page which is getting used very late in the future. Okay, so this is the page which I can replace. Okay, because it will be used very far in the future. Okay, so I will say okay, 5 will replace this 4. So this is the new content. Okay, now see 1. So 1 is already here, so there will be no page fault. Again 2 is already here, no page fault. So here no page fault, no page fault. Okay, now 3, will it generate page fault? Yes, because 3 is not present here. Okay, so I have to replace any page out of 1 to 5. Okay, I am currently here. Okay, so which page should I replace out of 1 to 5? So here you can see here we have the 4. Okay, and 4 is not here. Okay, so I will not take that page into consideration. Simple. Now next page is 5. So here you can see 5 is here. Okay, so okay, 5 is here. Now after that my reference string is over. Okay, so I will not replace 5. This is for sure. Okay, because 5 is getting used, right? Now after this we can see 1 and 2, they are not getting used actually, right? This string is over and we can say okay, 1 and 2, they are not getting used in the future, right? But the question is out of 1 and 2, which page should I replace now? Because 1 is equally good candidate for the replacement and 2 is also a good candidate for the replacement because both are not getting used in the future. So here we have tie. Okay, we have two candidates which can be replaced, 1 and 2. Which should I replace? So here I will apply the simple FIFO. Okay, FIFO means first in first out simple. Okay, the page which came first in the memory, okay, that should be replaced. Okay, and the FIFO says the same thing, right? So out of 1 and 2, which is the page that came first in the main memory? Here. Okay, so here you can see 1 came first, 2 came after 1. Okay, so I will replace 1 here according to the FIFO page replacement algorithm. So I will say on 3 I will replace this, so it will be 3 to 5. So 3 generated the page fault. Okay, so this is take. Okay, now let's see 4. So 4 is not here, so 4 will generate page fault. Okay, now the question is which should I replace? Okay, which page should be replaced? So 5 is getting used, right? Okay, 5 is getting used in the future, but 3 and 2, they are not getting used. So again here we have tie. Okay, tie was here also and here it is also tie. So out of 3 and 2, again I will apply the FIFO. So out of 3 and 2, which is the oldest page which came in the memory first, so here you can see 2 came first, then 3 came. Okay, so 2 is the oldest page. Okay, according to the FIFO page replacement algorithm. So I will replace this 2. So I will say 3, I will replace this. Okay, 3, 4, 5. Okay, and now last page is 5. So 5 is already here, so there is no page fault for 5. So this was the optimal page replacement algorithm. Okay, so if we count total number of page fault, how many are these? So 1, 2, 3, 4, and then 5, then 6, then 7. So there are total 7 page fault. Okay, the count of the page fault is 7, right? And in the FIFO page replacement algorithm, we saw for the same string we got 9 page fault. So this was the example. Okay, the same reference string was there and we applied the FIFO page replacement algorithm. So here we can see we got 9 page fault, right? So I hope you have understood that how we applied this optimal page replacement algorithm. Only thing that we have to take into consideration is whenever we are at particular page number, just see in the future. Okay, just see in the future which page out of these pages. Okay, you have to take care out of the currently allocated or currently present pages, which page will be used very late in the future. You can replace that page or you should replace that page according to optimal page replacement algorithm. Okay, just you have to take care of this. And whenever there is a tie, you have to apply the FIFO page replacement algorithm. Whichever page came first in the memory, replace that page. Okay, so before ending the video, let me tell you, optimal page replacement algorithm is actually a theoretical algorithm. That means this algorithm is actually not implemented practically in the systems. Okay, this is actually just a, you can say, a benchmark for measuring the performance of the other page replacement algorithms. Okay, this act as a reference algorithm. And why it is not implemented practically? The reason is simple. We cannot look into the future. Why? Because when we are working with the real system, for example, in that system, the page number 1 is asked. Okay, after that we cannot tell whether page 2 will be asked or 3 will be asked. Okay, this is just a snapshot. Okay, after that, let's say 2 is asked. Okay, that is okay. After that 3 is asked. Okay, so in the frames we say 1, 2, 3 are present. Okay, all generate page fault, that is okay. Now after that, when 4 came and there was a need to replace a page, okay, so that 4 can be put inside. So we are saying just see in the future, okay, whichever page is getting used very late in the future, replace that page. But we are currently at 4, okay, and these page numbers, they have not actually been generated by the CPU. Okay, let's say at t equal to 1 p.m. the 4 page number was demanded. Okay, this page number was demanded. Currently it is 1 p.m. We cannot say at 1:15 p.m. which page will be asked. 1 will be asked, or at 1:20 p.m. 2 will be asked. Okay, we have no like prior information. Okay, so how we can tell that which page will be used very late in the future? Okay, so that's why this is like a theoretical algorithm. Okay, this is just acting as a benchmark. Okay, and actually optimal page replacement algorithm is actually the best page replacement algorithm out of the other page replacement algorithms. Why? Because actually future is the best indicator which can actually tell me that which page should I replace. Okay, replace that page which will not be used in the future. Simple, right? So you can replace that page and that will be actually a good indicator that by replacing that page I will get lesser number of page faults, right? So that's why this is the best algorithm. But as we cannot see predict the future which page will actually be referenced, okay, that's why this is not implemented practically. Okay, and we have to take care that this is the snapshot that is given, okay, for a particular time period. Okay, but in the real system at a current point of time we cannot say what will be asked or what page will be demanded in the future. Okay, so I hope you have now understood that how we can apply optimal page replacement algorithm for a given example. And I would recommend you that you apply the same optimal page replacement algorithm on this given string with 4 allocated frames. Okay, you start with the 4 frames and you apply the same optimal page replacement algorithm and see how many number of page faults and how many number of page hits you will be getting. Okay, so just to tell you, if you want to find the page hits, then page hits means the page is already present in the main memory. So we have 1, 2, 3, 4 and 5. Total number of 5 page hits. Okay, so you can find the page hits this way also. Total number of page numbers. Okay, total number of page numbers here are actually 12. These are 12 page numbers. So if you subtract 12 minus and then total page fault was 7, then also you can get the number of page hits. Okay, and if you want to find the ratio of the page faults, okay, in the percentage you want to, let's say, find out. So out of 12 references, these are the 12 pages. Okay, out of 12, how many page faults were generated? So page faults was 7. Okay, 7. So you will get 0. something 58. Okay, if you multiply it by 100, you will get like 58%. Okay, so you got 58% of the page fault. Okay, so the question can be asked in one or the other way also. The main thing is you should know that how we can find the page faults, okay, by the optimal page replacement algorithm. So this was all about this video. See you in the next video with next example. Till then, goodbye.